Right, let's dive straight into this brilliant chemistry survival toolkit designed specifically for your Year 9 revision. Now, I was told you already remembered the acid plus something rule, and let me just say, that instinct is absolutely spot on. You've already got the foundation. In this explainer, we're going to build right on top of that excellent memory so you can walk into your chemistry exam feeling completely unstoppable.
To get you totally prepped, we're breaking this down into 5 bite-sized chunks: making salts, meeting the reactivity series, the chemistry dance floor, extracting metals like Minecraft, and finally, mastering mass and yield.
Okay, part 1, making salts and the M.A.S.H rule.
Let's start right in your safe zone. The absolute key here is mastering 3 simple acid plus rules. If you know these, you can predict pretty much any reaction they throw at you. Number 1 is the M.A.S.H rule. Metal plus acid produces a salt plus hydrogen. If you did this in a lab, you'd actually see that hydrogen gas bubbling away. Number 2 is neutralization. Alkali plus acid gives you salt plus water, basically canceling each other out. And number 3 is the volcano effect. Carbonate plus acid creates a salt, water, and carbon dioxide. That gives you massive fizzing, exactly like mixing baking soda and vinegar. Oh, and a quick cheat code for the salts. Hydrochloric acid produces chlorides, sulfuric acid makes sulfates, and nitric acid creates nitrates. Easy.
Moving swiftly on to part 2, meet the Reactivity Series.
Now, don't let the formal name put you off. It's basically just a ranking of how energetic different metals are. And this actually explains the tech you use every single day. Up at the top, you've got highly reactive metals like lithium. Because it's literally bursting with chemical energy, it's perfect for the lithium-ion batteries powering your phone. Down at the bottom, we have completely unreactive metals like gold and silver. They don't react with oxygen or water, so they never rust. That makes them brilliant for jewelry, sure, but also absolutely crucial for the tiny, reliable connectors inside your computer.
So how do we actually remember this list for the exam? Just use this classic school trick. Please stop calling me a careless zebra, instead try learning how copper saves gold. If you can remember that rather silly sentence, you've memorized the order from most to least reactive. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, and gold. And yeah, you'll notice carbon and hydrogen snack in there. They aren't metals, but they're super important reference points for when we extract things later.
Right, part 3, the chemistry dance floor.
Now we know who the energetic players are. Let's take them to the chemistry dance floor. This is all about displacement reactions. In a displacement reaction, a highly energetic element literally pushes out a less reactive element from its compound. Think of it exactly like an overenthusiastic dancer cutting in on a slower couple on the dance floor. Picture this. Sluggish copper is currently paired up, happily dancing with chloride. Together, they're copper chloride. But wait, highly energetic zinc has just stepped onto the floor. Think back to our zebra mnemonic for a second. Zinc is way above copper on the reactivity list. So what on earth do you think is going to happen next? You guessed it, zinc is far more reactive, so it effortlessly shoves copper aside and steals chloride as its brand new partner. Boom, we've got zinc chloride, leaving poor, sluggish copper standing all alone on the sidelines. That right there is a displacement reaction. Part 4, extracting metals, exactly like you do in Minecraft. What's really brilliant here is that we use that exact same dance floor logic to dig valuable metals out of the ground. Most metals in the Earth's crust aren't just sitting there pure and shiny. They're trapped inside rocky compounds called ores. An ore is simply a rock containing enough of a metal to make extracting it worth the effort. And we have to use chemistry to break them free. So, just like chucking iron ore and coal into a Minecraft furnace, in the real world, we use massive blast furnaces. Coal is basically pure carbon. Because carbon is more reactive than metals like iron or lead, it displaces them, sealing their oxygen and leaving pure iron behind. We call this carbon displacement. But if a metal is wildly reactive, like aluminum, which sits above carbon, carbon isn't strong enough to cut in on the dance floor. For those super reactive metals, we have to zap them with electricity in a process called electrolysis. And it's not just about extraction. Check out this catalytic converter from a car exhaust. It uses transition metals. Those are the ones sitting in the big middle block of the periodic table, like palladium, platinum, and rhodium. These metals act as catalysts. That means they can drastically speed up a chemical reaction, turning toxic exhaust gases into safer ones without actually getting used up themselves. Pretty clever, right? Finally, part 5, mastering mass and yield.
Home stretch now. Let's tackle the maths. And look, I know maths in chemistry sounds a bit daunting, but I promise, it's literally just simple adding up. First up, relative mass. To find the mass of a whole molecule, you just add up the masses of its atoms. Take methane, CH4. That's 1 carbon atom and 4 hydrogen atoms. On your periodic table, carbon is 12 and hydrogen is 1. So your calculation is simply the 12 from carbon plus 4 times 1 for the hydrogens. See, it's just 16. You've completely got this. Calculating relative mass is actually beautifully straightforward. But why bother calculating masses at all? Well, it helps you figure out your percentage yield. Percentage yield just tells a chemist if the reaction actually worked well. It compares the actual mass of the stuff you made in your beaker versus the absolute maximum theoretical amount the math said you could have made. You just divide your actual yield by your theoretical yield. If that number is close to 100%, mate, you are winning. That means you have a high percentage yield. This is fantastic in real-world chemistry because it means you've minimized chemical waste, making the whole manufacturing process way greener and cheaper.
There you go. Armed with the trusty M.A.S.H rule, your brilliant dance floor displacement skills, that Minecraft extraction logic, and a totally solid grip on the maths, you are absolutely primed for this Year 9 exam. You hold the keys to the toolkit now. So my final question to you is, what incredible real-world chemical reaction are you going to decode next?